Hey everyone, so I hope that you have watched the video on number line. If you haven't, the link would be on the top right. I would request you to click on that link, watch that video first, and then come and solve these 3 questions. Okay, if you have liked that video, if you've already seen the video, if you have liked it, I would request you to like that video and subscribe to our channel too. Okay, so now let's start off and discuss this question. Now, if you have gone through that video lesson, you would have now understood that when you're solving a question like this, where higher powers are involved, we don't actually have to find out the value of these numbers. Okay. Also, the value that is given to us, like in this case, we are told that a is equal to minus 0.5. We don't even need to actually use this value. We can take any value that we are comfortable with, as long as it lies in the region that is being talked about, we are okay. So for example, in this case, a is equal to minus 0.5 lies in the third region, right? So let's write it here. This is my third region. It lies in this region. So if I'm not comfortable working with minus 0.5, I can take my minus 1, minus 0.1, anything that works with us, you can take and start solving the question. Okay. Also, it would be great that, as I told you, that if you remember the pattern for region 3, how it works for odd powers, and how it works for even powers, then you would be able to solve the question. This question can be solved, actually within 30 to 40 seconds, actually, not more than that, if you know the pattern. And I'll write the pattern here first, and then I'll show you how quickly you can solve it. Now remember, I told you that if it's an even power, the value would be positive. And this would, if the value is positive, then in that case, it would behave in a similar manner as powers in region 2 behave. Now we know that in region 2, if the power is high, the value is low. So we can say if I take a higher power, let's say for example x to the power 4, the value of this would be less than a lower power. Okay. So to generalize it, for example, we can write it like this. For an odd power, the pattern would reverse. If you remember this much also, then we'll be able to say, hey, that means that if I have a higher power, so for example, x to the power 3 would be greater than x to the power 1, or x to the power 5 would be greater than x to the power 3 would be greater than x to the power 1, and so on and so forth. If you remember this much, we'll be able to solve the question very quickly. And obviously, it is logical, if you remember this part also, that even powers are positive, right? So in general, even values, the value that we get from here for even powers would obviously be greater than the values that we get from odd powers, right? Because for even powers, the value is positive. And for odd powers, the value that we'll get will always be negative. Okay, now with this in mind, let's look at the answer choices. Now, obviously, the one that is written out here this is the greatest value, obviously. And if you look at the powers, we can see there are 3 powers. One of the power is a to the power 11, a to the power 31, and a to the power 20. Now, if you look at the inference that we have drawn here, we can very easily say, hey, even power will have the greatest value. Obviously, it has to have. Okay. Now, the moment we make that inference, we can be sure that our answer won't be D, C, or A. We can cancel it immediately. Okay. So we'll be left with B and E. Now, if you look at B and E, we need to figure out what happens in case of odd powers. Now, in odd powers, we know the higher the power, the greater the value. Okay. So that means x to the power 31 will have a greater value than x to the power 11. We have a greater value than x to the power 11, and so this would be our answer. And we'll mark option E, and we are done with this question. So as you can see how easy it was. A to the power 20 has to be the greatest. With this, we eliminated 3 options. And after that, if you remember this part, then we'll be able to solve the question much more quickly. Even if you don't remember, as I told you, you could have taken a value such as, you could have worked with this only. You could have found a to the power 1 and a cube, and then figured out which one would be greater, and then replicated it in the for these powers. Okay. So I hope this is clear. I hope you can now appreciate why knowing the number line can actually help you solve the question much more quickly. Okay, now let's go to the next question, which is an interesting one. In this question, there's a small chance that you may fall for a trap, especially if you have solved this question and say, if you haven't, I would request you to pause and solve it, by the way. But if you have, some of you may have marked the answer as A. And here's where I wanted to talk to you about a bit more about the number line, because there's a small chance that you might make a mistake. Now, let's read the question stem. The question stem is pretty simple. X is a real number. Okay, if it's a real number, that means it could be positive, it could be negative, no, it could be an integer, it could be zero also, by the way, it could be an integer, it could be a fraction, everything is possible, everything is on the table. I need to figure out, is x square greater than x cube? Okay, that's my question. Now think about it. Let's look at the number line. Okay. They are asking me whether a lower power is greater than a higher power, or in short, whether the higher power is less than the lower power. Now, per our understanding, we know that in region 1, higher power has a higher value. Okay, so obviously they are not talking about region 1, that we can be sure of. Okay, they are not talking about region 1, because in this case region 1 won't work. Okay, if it doesn't work in region 1, obviously it would definitely work in region 2, right? In region 2, we know that the higher power has a lower value, so maybe they might be talking about region 2. I need to figure out whether x is between 0 and 1. Okay, that's one case which is possible. Let's look at another case. Obviously in region 3 also, or region 4 for that matter, in these two regions also, x square would have a positive value, right? X cube would have a negative value, right? So I can say that they might also be talking about this range. Okay, so they might be talking about this range, they might be talking about this range, they might be talking about this range. And with this, you may come to that conclusion that, hey, they are talking about, is x less than 1 or not? Okay, if you do that inference, very good. I'm happy that you're able to come to this conclusion. It's pretty awesome. Okay, but there's one mistake that you might have made. The mistake that you might have made is that you did not check for x equal to 0 and x equal to -1. Remember, I told you that these regions do not consider these three values. Okay, so I'll have to check for all these three values that what exactly is the situation. For example, if x equal to 1, okay, then x square is not greater than x cube. They're basically equal. Okay, if x turns out to be 0, then also in this case x square is equal to x cube. If x equal to -1, then in this case there's no problem, obviously, because x square would be 1, x cube would be -1. So in this case I can say x square is greater than x cube. So if for some reason if I figure out that x equal to 1 or x equal to 0, then my answer becomes no. Since the question is x square greater than x cube, the answer would be no for these two cases. But apart from that, if x is less than 1, okay, if I know x is less than 1 and x is not equal to 0, then in that case my answer would be yes. Okay, so this is very important, because if you miss the fringe, the 3 points that are there, you don't figure out what happens in these cases, there's a good chance that you would fall for that trap. Because if you look at option 1, let's go look at statement 1, x is less than 1. Now you might be very tempted, if you would have looked at these three regions, you would have said, hey, this is sufficient, I'm done, let me mark A as my answer, but that is wrong. Because x less than 1 also includes x equal to 0, right? So if x equal to 0, the answer is no, x square is not greater than x cube. Apart from that, for rest of the values, x less than 1, -1 when x is not equal to 0, the answer is yes. Okay, so since you're getting two contradictory cases, you'll say that this is not sufficient. So the answer cannot be A or D. Okay. Second statement is, if you look at S2, x is positive. When x is positive, that means x is greater than 0. Okay. Now, if x is greater than 0, what is going to happen? Out of these three regions, let's look at these three regions and see what is possible. But notice x is greater than 0 includes two regions, region 2 and region 1, right? It includes region 2 also, it includes region 1 also. Now in region 2, if it lies in region 2, then my answer would be yes, x square is greater than x cube. But if it lies in region 1, then my answer would be no, right? That x square is not greater than x cube. X square is basically less than x cube. Okay, so notice once again you're getting two contradictory answers. Since you're getting two contradictory answers, even B won't be your correct. Okay, so when you combine, what's going to happen? When you combine, notice we know that x is less than 1. We know from statement 2 x is greater than 0. So this boils down to x is between 0 and 1. And now we have a clear-cut region 2 with us, and we know that in this case the answer is yes, x square is greater than x cube. So the answer is going to be option C. So is this clear? Now in a yes/no question, I'll add one more point. I obviously took 3 regions to solve it, but you could have written down all the cases. Okay, you could have written down that in this region my answer would be yes, my answer would be yes, my answer would be yes. Here the answer would be no, and obviously the fifth case would be when x equal to 0, the answer would be no. You could have explicitly written down these cases and then moved ahead and solved the question. Now you might say, hey Saket, there's a lot of effort out here. Why are we even doing this? Understand, if you're just dealing with exponents chapter, then in that case, and if you don't know anything else, even if you don't know how to work with inequalities, let's say if you've forgotten how to work with quadratic inequalities specifically, then just knowing the regions can help you get the answer. That's my main point. Okay. However, keep in mind, if you know quadratic inequality, if you learn this well, then when you're dealing with x square is equal to x cube, you can actually figure out when this would be yes by solving this. Okay, I'm not going into this because obviously that's not the scope of the discussion, but knowing quadratic inequality can help you figure out that the range would be 1, 2, 3. It will not be that difficult to figure that out. Okay, that when the answer would be yes. But in this case, as you noticed, finding that region, these 3 was very easy if I know what my 1, 2, 3, 4 is. So what my recommendation would be, make a summary of this, take a printout of it and keep it with yourself somewhere where you can keep on looking at it every day. Because notice for us, for me it was pretty intuitive, right? I could write down all these 3 cases in one shot. I knew what are the things that I need to check also, 0, 1, -1. So as a takeaway, remember, you do check these 4 regions, and if nothing is mentioned, or if it is clearly given that x is a real number, that means it will include everything, then in that case, you check for all cases, which is -1, 0, and 1 also. Okay. Now let's solve our last question, which I think is the trickiest of the lot, but obviously we can solve this question quite easily once again with the understanding of the 4 regions. So let's very quickly see what we have here. We are given that P, Q, and R are 3 numbers, so nothing is mentioned out here. What kind of numbers are they? So I'll simply assume that they are real numbers. That's point number 1. Okay. Now, obviously, they could be negative, positive, integer, fraction. So I can take any of the 4 regions that are required. Region 1, region 2, region 3, and region 4. Any values are possible. We are also given that p square, smaller power, is greater than q cube, is greater than r to the power 5. So notice when the power is increasing, the value is decreasing because see, p square is greater than q cube. Okay, so that is also one thing that we'll keep in mind. We'll not try and find out in which cases this will happen, in which case will not happen. We'll leave it as is. Obviously, we can try and figure it out, but that would be a waste of time because we don't know what else we need to do. So we'll leave it as is and read along. So it's given that which of the following statement could be true. Okay, so I have a question which says could be, which means I need to look at all possible cases. I don't need to look for one definite answer. Okay, so any case, any of these could be true based on whatever is given to us. Okay, so let's look at each statement one by one. The first statement is P is greater than Q is greater than R. Okay, so see, they're telling me that P should be greater than Q should be greater than R, and P square should be greater than Q cube should be greater than R to the power 5. Because if this is true, think in this way, if this is true, then I want this also to be true. This has to be true because this is given to us, right? So let's assume this to be true and see, by assuming this to be true, can I prove that this is also true or not? If I can do that, then that means this is possible. Now notice in this case, If I want to do that, obviously if I want p square, let me write it parallelly, should be greater than q cube, should be greater than r to the power 5. Wouldn't it be in my interest that I choose some values from region 1 where the value of p is very high? And see, I'm just thinking logically. Why should be it high? Because so that when I do p square, I get a very high value. The value of q should be lower than obviously p. And so for example, let's say for example in region 1, I take this as p as 10. Okay. So 10 square would be 100. Okay. Now I need to choose a value of q so that when I do a cube of that, I get a value which is less than 100. So for example, I can take this as say 3. I can take q as 3 because if q is 3, then this is 27, right? Q cube would be 27, which is fine. And r, I can simply take it as 1 if I want to for the sake of simplicity, because then it would be 1. So notice if I take values from region 1, obviously 1 is not included in region 1, but it is, one value that I'm taking. I could have even taken some other value, but then I would have to change this. But why do that? Okay. So I've taken this as 1, 10, 3, and notice, but just by using values from region 1, I was able to figure out that p could be greater than q, could be greater than r, because it satisfies p square is greater than q cube is greater than r to the power 5. Okay, so I hope this is clear. So all you need to do is try and assume that whatever is given to you is true, and then on the basis of that, you try and prove this one. Now, if 1 is true, what I usually do is I cancel out the cases which I can definitely eliminate. So I'm eliminating B and C. Okay. Now notice I can go to 2, but don't you think it would make sense if I try 3 first? Because if 3 is wrong, I can eliminate this. If 2 is wrong, oh no, it makes sense to do 2, because if 2 is wrong, then I would be able to eliminate both of them. Okay, so let's look at 2 only. Makes sense. Now 2 is p is equal to q is equal to r. All three of them must be equal. Okay. Now think about it. I want all of them to be equal, but I also want to ensure that a higher power, okay, a smaller power has a higher value. High value, small power. Now where did we learn this? Where does this work? With a smaller power you get a higher value. This only works in region 2, right? We can take region 2 because in region 2 I know that a smaller power will have a higher value. And if they are equal, then they are technically asking me to figure out, hey, is p square greater than p? Can I prove that p square is greater than p cube is greater than p to the power 5? Which I can easily. I can take the value as 1 by 10. Okay, if I take all of them as 1 by 10. Then obviously 1 by 100 is greater than 1 by 1000 is greater than 1 by 10 to the power 5. Right? So notice how easy it was. I know in which region this works, and I could easily figure out in one shot that which region I need to look at. No hit and trial, no taking 1, 2, 3 first, then -1, -10, then 1 by 10, nothing like that. Logically knowing where things work and going there and attacking it. So even 2 can be true for region 2. And again, understand I'm doing a question which is based on could be true. So I can look for all possible cases. So if 2 is also true, then everything boils down to D and E. Okay, so let's look at the third one, and I'm doing the third one here only. R is greater than Q is greater than P. Okay, this is interesting because you notice the power that I have here where P, Q, R is written like this just reverses out here. Okay, R should be greater. The value of R should be greater, but when I try to find out R to the power 5, that should become less. Okay, so where can this work? Where will this work? Where you take the highest value as r, but when you find r to the power 5, it should be smaller, and when you find p square, it would be greater. Okay. Now remember, when did I say that for even power the value would always be positive? I said that for negative regions, right? I said for region 2 and region 3, didn't I mention that for in the video, if you haven't watched it again, I would recommend looking at it, that if obviously for even powers, the value would be more than the odd powers. So one hint or one inference that you can draw is, so let me look for a case where I am looking in the negative values. Okay, that's number one. Now, should I go to region 3 or region 4? That would be in your mind. Now, think about it in this way, that R should be greater than Q. Okay, but when I'm finding out the power, it should reverse. Okay, Q cube should become greater than R to the power 5. Okay, now remember, we talked about it that if we are doing this, then that is possible for region 4. What did I say for region 4? I said for even powers, it works in the same way as region 1 for even powers. For odd powers, it works in the same way as region 2. When in region 2, we know that smaller power has a higher value. So I'm looking for a smaller power with a higher value. So what I can do is I can simply start looking for a case like this. So for example, I can take a case, say R should be greater. So let's something like this, -3, -4, -5. Okay, -3 is greater than -4 is greater than -5. Now let's see if I can satisfy this or not. P square would be how much if I do P square? P square is going to be 25. Okay. Q cube would be how much? Q cube would be -64. 4 times 4 is 16. 16 times 4 is -64. Okay. How much is R to the power 5? Now, if I do R to the power 5, that would be -243. And -64 is actually greater than -243. So I can see that everything works out if I consider this for region 4. So in short, the correct answer in this case is going to be option E. A difficult question, especially difficult if you don't know the regions and if you don't know how to logically figure out which values to use. So notice I did not attack this question by taking values randomly. If I would have done that, then it would have been very difficult for me to figure out, or I would have ended up taking multiple values multiple times, some positive, some negative, and wasted my time. I logically decided to first of all figure out in which region should I go and look for values. Like for the third case especially, I noticed that I need an even power which should be positive and odd powers which are which should be less. That helped me understand that I should look for either region 3 and region 4. Or region 3 or region 4. Then I looked at Q to the power 3, R to the power 5. I realized for a smaller power, I need a higher value. And I know that works for region 4. So I took values from region 4 and checked whether it's working or not. Since it was working, my job was done. Okay. So the learning and takeaway from all these questions, exponent related questions, is that if you're not able to simplify, especially why I'm adding this point, because if you're able to simplify, then there's a chance that you might be able to solve this question using quadratic inequality, not this one, but any questions like where powers are involved with quadratic inequality. But in questions like these where powers are involved, the variables are also not the same, P, Q, R are all different variables, and you're trying to get the answer. In that case, 4 regions can be your best friend. It can help you figure out what values need to pick to solve the question. So don't take random values to solve question. Make sure that you understand these 4 regions really well so that you can decide which regions to choose and how to get these values. So I hope this is perfectly clear, guys.